Today, we're looking at the world in a new light. And with our different perspectives, we can accelerate opportunities to create value that lasts. How will you take advantage of the connections you make this week? How will you see connectivity unleashed? As the boundaries blur between online and real life, we continue to rely on digital innovation and connectivity to transform our world. From the metaverse and NFTs to connected devices and IoT, this year's MWC themes will spark bold new ideas to create a positive future. As an industry, we pave the way for transformation and find new ways to help other industries innovate. And now, together, we continue our exciting 5G journey, delivering on our industry's commitments to tackle the mobile internet usage gap and reducing our industry's carbon footprint, creating a better future for all. Because together, we will unlock the full power of connectivity so that people, industry, and society thrive. This week, in our iconic host city of Barcelona, we will put our convictions to work for our businesses, for our next generation of leaders, and for the world. Are you ready? It's time.
Hello everyone, pleasure being here today after 2 years being back on stage. It's Ali Riba here, President and Data Anthropologist of Riba Analytics Group. Digital twinning is not just about creating a virtual replica of machines and equipment. You can create a digital twin for a livestock, or even for the entire Earth itself, or for a business strategy. And also, I have seen initiatives to create digital twins of humans. But when we talk about digital twins of humans, we can create a virtual, where a human could live in a virtual world, and even if they are deceased, they can still live there. But that would only replicate things like persona, memory, or voice tone. But in order to create a real digital twin of a human, that would require phenomenology. That would also require understanding experience and embodied relationship with our environment. And that is a capability that's not yet available to AI now. We have also been living in uncertainty. And organizations are trying to react proactively to disruptions like climate change, stockpiling, panic buying, and pandemics and geopolitical instabilities. And they are trying to gain advantage from these disruptions. There is a quote by philosopher Ludwig Wittgenstein where he discusses the topic of uncertainty, where he said, "One cannot begin to doubt without being certain, without first believing a set of propositions to be true." And digital twins would help us start to have this tolerable measure of certainty. And yes, it's still uncertain to know now where will the digital twin technology and the metaverse will exactly look like in the next few years. That's why I'd like to continue this discussion with our esteemed panelists today, who will shed the light on the opportunities of digital twin technology in our homes, in our cities, in our factories, and how will this technology shape our human experience. I'd like to welcome them on stage. Welcome. We have here Timon West. Timon West is the Vice President of Augmented Reality, Virtual and Mixed Reality Tools at Unity, managing a team of cross-disciplinary artists and engineers to push the technical boundaries on how we can create a future we all want to live in. Claudia Garcia. Claudia is heading up technical sales support for Ericsson, where she is a member of the leadership team. She focuses on enabling sales globally. Bijou Nair, who is the president of Assurant Global Connected Living Business Unit, which delivers comprehensive services, support, and protection for the connected consumer. We also have Tommy Björger, who is the director within the CTO group at ZTE Corporation, focusing on 5G, and Tejas Rao, who is the managing director and global 5G offering lead for Accenture's network practice. Timony, back in the Iron Age, the motifs on ceramics communicated anthropomorphic features, but then in the digital age, our UX became screens, and then it was augmented in the data age with conversations through voice assistants. How do you envision the user experience of digital twins and their foundational effort in the metaverse concept?
Sure, thank you. That's a great question. So the way we tend to think about it at Unity is less about an overall concept of a metaverse, because we create the tools that anyone can use to make any sort of subset of what they think that is. What I instead focus on is how our relationship to computers has changed. So if you go back to the early days of mainframe computers, you had a computer that was in another room, in another building, and had non-human readable programming. Then we got human readable programming, which I consider one of the first big shifts in human-computer evolution. Then we started to miniaturize computers. Instead of being in someone else's house or only at work, they started to be in your home. And around the same time, they also became networked. So not did you only have access to the information on your computer, but you had information access on any computer, right? So in each of those steps, we see our relationship to computers changing. And largely, that relationship was, how quickly can I get information from somewhere? So we started to depend on computers for just access to better information, which, obviously had significant advantages, allowed us to talk to each other, probably ended a lot of bar fights where people didn't have to argue about trivia facts anymore. Instead, you could just look it up on the internet. But then we came to the era of true miniaturization and wireless networking, and that started in the 90s. And this allowed computers to not only give us information that other humans had recorded, but started to give us information about the world itself. So we started to understand where the phone, for example, was, not just getting information from the phone, but it had a GPS, and we could use it to see where you were. And now, fast forward another 20 years, we find ourselves in an era where all computers, including all of the tiny little phones that you're carrying right now, are chock full of sensors and machine learning that can do everything from know where you are, to recognize your face, to recognize your voice, and so on. And this has just created a wealth of real-time contextual information. And I consider this the next wave in human-computer evolution. So not only are we depending on computers for information, not only can computers, and I'm using this very loosely, by the way, I include, devices, robotics, it could be self-driving cars. All of these devices now have world awareness, new contextual awareness. So they're not just networked, but they truly understand what's going on around them in a human coherent way, let's put it that way. So in terms of how we're going to interact with them, I think this is a gigantic leap, and I expect it to take another 50 years or so, where computers go from being things that we have to learn to interact with to something that learns to interact with us, that genuinely starts to take on human capabilities of contextual awareness. And it does so by intaking camera frames and analyzing them, understanding object recognition and semantic analysis, and so on and so forth, everything that makes virtual reality possible and robotics possible and self-driving cars possible. And then it will start to, I think, move towards, if you've ever seen Star Trek or really almost any science fiction movie, where computers can kind of intuit what you wanted. They can intuit, they can parse a sentence and actually have branching feedback. So that's what I expect to see over the next 10 years, is a significant rise in contextual awareness for human-computer interaction. It's subtle, and I think It's been disappointing, you know. Anyone who's ever used Siri knows very well that that it's not quite there. I call it like the uncanny valley of voice recognition. But I do see a future where this will start to be the norm.
And that's very interesting. So moving from the user experience side of things to cities, Claudia, in Ken-directed human-centered cities devices will share resources to offer more computational power to other devices, be it drones, connected cars, mobile CCTV cameras, based on the need of each node and based on the decision type needed in a city. If we go down to the infrastructure level, how are you ensuring power optimization when deploying 5G sites at Ericsson?
Yeah, so in Ericsson, we are leveraging digital twins in commercial solutions where we use the power of AI, data, and digitalization to enable the network of the future. So we have actually developed both a network, digital twin, that models the invisible part of the network, all the signals and how they propagate in the air, and then also a site digital twin that models what we see of the network, the towers, all the equipment on the ground, and so on. So if we take it to the network digital twin, which is the one we use for power optimization, this story is very closely connected to our customer, Swisscom. This is an operator in Switzerland who runs one of the best networks in the world. And they are also subject to some of the most strict regulations when it comes to radiated power emissions. So they knew that in order to allow for 5G, they needed to lower the radiated power from some sites. But this was evidently not very easy to know, okay, where can I lower the power without harming coverage or user experience? So we knew that with manual methods or traditional rule-based automation, we couldn't really cut this problem. So we explored the use of reinforcement learning, which is a machine learning technique that traditionally has been used for things like chess games or driverless cars, where you have an agent that interacts with the environment, takes actions, and then based on the feedback he receives, he will decide another action, and little by little, it converges towards a long-term goal. But then we knew, okay, our long-term goal is to lower the transmitted power. But we can't be playing with the radiated power because we could violate the regulation, which is what we are trying to avoid in the first place, right? So that's where the network digital twin comes in. So we are creating an accurate enough copy of the network that is able to model the coverage, the interference, and even how the subscribers move across different frequency layers, while being sufficiently simple to be scalable enough to be run in a commercial application. So then we developed these two things, the network digital twin and the reinforcement learning agent. We let the agent convert thousands of rounds, and then when we implement the changes in the network is where the magic happens. So we were able to lower the radiated power by 20%, lowering the energy consumption by 3.5%, and then improving the user experience by up to 30%. So you might wonder, okay, what kind of sorcery this is, right? You radiate less, and then the people have a better experience. But I think by this point in time, you have all been to the restaurants in Barcelona, right? So sometimes they're very noisy. So if everybody's shouting more doesn't really get you anywhere. So a mobile network is a little bit the same. So if we all lower our voice, then we can actually all have much better experience.
Amazing. I believe that's the first step towards reaching that resource sharing among devices in a city. So moving from cities to factories, I'd like to discuss with Tommy. During the industrial age, technological change help increase the efficiency of coal consumption. With the current needs driven by supply chain disruptions and based on your work at ZTE, how would digital twins deliver greater manufacturing efficiency?
It's a great question. Personally, I hope we stop using coal power at any way, shape, or form sooner rather than later. I mean, at ZTE, I think we're in a very, very unique position. You know, we're an ICT company. We provide solutions, but we provide solutions that can really help decarbonizing the planet, that help other industries. So, for example, I mean, we're here to discuss digital twin. Digital twin is, like I say, it's not a new concept. You know, it's been around for years. You know, you can go into any computer game and you will find visualizations of real world objects in computer games, etc. But you know, how do we take that and how do we do something tangible with it? And actually, why is now the time? So I would say now we've reached a point in time where you need three things to make digital twin works. First, you need the digital platform. So you need the AI, the machine learning, the databases. We also need that cost-efficient computing and storage, which I think we kind of achieved now. We also need the networks to transport the data. And with the power of 5G, we now have those data networks. You know, we can shift bits and bytes from A to B, very cost efficient, very fast, there's very low latencies. And the last thing we need to make this work is sensors, like we talked about here. Today, there is a lot of sensor technologies out there. We have sensors in our phone, you know, we put sensors in our home, it's in the ground, it's all around us. So taking all that information and applying it, so let's say we apply it to a Industry 4.0 environment. So we work a lot with our customers to improve decarbonizing industries, for example. I'll give you one example. In Yunnan province in China, we work with a very, very large aluminum smelting manufacturer. And if you've ever been to a, you know, aluminum smelting facility, it's huge. We're talking, you know, kilometers of warehouses and smelters. There's a lot of moving parts. It's a very hazardous environment that uses a lot of energy. So we were able to provide sensor technology, 4K, 8K camera technology, the private 5G network to securely and fastly move that data into a digital twin model to completely model the factory, model everything from processes to how people is moving around, how machines are doing, and collecting vast amount of data. And by doing so, in that specific case, we were able to reduce power consumption with 90 million kilowatt hours per year, just in one factory, by using digital twin, the power of 5G, and sensors combined. And also, you know, we also make 5G equipment, consumer devices, etc. We have one of our own factories. We completely, fully made 5G together with the digital twin. So again, we modeled the whole process flow. We modeled in the digital world the, you know, manufacturing, how robots interact with each other. In a factory, you might have a hot zone where you do soldering on a circuit board. Then you have a cold zone. You might have another hot zone where you cure materials, shape materials that eventually become our products. But one thing we can do in the digital world is we can see things we can't see with our eyes. So we take all this sensor data, we feed it into the digital twin model, and then we start looking at the different layers. I mean, I can sit in front of a screen and I can literally see with my own eyes the airflow going through the factory. And you can see, well, actually, that's not right. I can probably save a lot on cooling capabilities and energy if I could change how that airflow goes. And the same with temperature, the same with how robots are moving around. One big thing as well for us is preventive maintenance of machinery. You know, by modeling these complex machines in the digital world and using cameras and augmented reality, you know, we can kind of calculate mean time between failure, and we can send out people to do preventive maintenance, but they can also overlay, you know, the virtual reality over existing physical objects using this kind of digital twin model. So it's really fascinating, but for us, it can really help to drive the decarbonizing of industries and drive efficiency. So I think for me, that's one of the key things that we can help to make a greener planet.
Of course, and with the rise of onshoring and reshoring after the pandemic and the rise of smart microfactories, there is a lot of opportunities in that area. So we discussed the opportunities in our factories, in our cities. What about in our personal lives and at homes? Bijou, I know you have been doing some exciting initiatives on digital twins of homes. Can you tell us more about what you are doing in that space?
Sure. Thank you, Ali, and thank you, GSMA. It's great to be back. I think everybody will agree that being back at the conference and able to meet people is just fantastic. Just to answer your question, let me put it in context a little bit about what we do in connected living at Assurant. We saw the GSMA little movie that was running earlier that talked about, you know, being able to letting businesses, industries, and consumers thrive, right? That's a little bit of what we do at Assurant with the solutions that we provide for devices and for home. we help consumers thrive in their connected world. So with the phones, we protect, support, repair, and help you recycle and repurpose those devices when they are end of life. Now, during the 3 years or so that consumers are hanging on to their smartphone, it becomes the hub of their home. And we've all learned that over the last, let's say, two years or so, when we've all been cocooned up at home during COVID, our relationship with our homes have changed. We are paying more attention to the connected devices at home. And roughly 72% of the people survived have said that they have difficulty connecting, configuring, using all these connected devices that we have at home. And they are rising every single day, right? The number of connected devices, if you think about how many you have them at home. So with the smartphone being the hub of it, where we are seeing market evolving is people, they don't want to be calling a different person for their support for their TV, et cetera. So the phone can scan and get connected to all the devices out there. So you essentially get a digital twin of what's happening inside of your home. And then if you have a problem, you can click on it, and a multimedia thing will show you how to get your dishwasher connected to your smartphone, or how to make a router function again when it just stopped functioning. It's most of the time you just unplug it and plug it back in, but we can get fancy about it if we want to try and fix that. In some of the countries like Japan, it's moving to a whole different stage. An entire apartment has an exact replica of a digital twin. Now, layout is pretty common. Almost everybody has that these days. When you go onto a website, you click on an apartment number and you can see how it's laid out, how many rooms it has, et cetera. But they've gone to the next step with some of our applications. All the appliances, the air conditioning units, sensors, connectors, et cetera, are out there. When was it manufactured? When was it installed? How many hours has it been running? Its service record, et cetera. So now you can click in there. If you're buying an apartment or renting an apartment, you can figure out how much to budget. Do you need to replace something in there? So you're getting a much more accurate picture of what you're trying to buy and what you need to do. So it's a practical application of a digital replica of your home or your apartment that you can use for either troubleshooting purposes, valuation purposes. And then furthermore, what industries are doing is they know the lifetime of certain chips or something that is about to fail. So they can automatically get a service contract out to that person by saying that, look, this has been running for, 1,000 hours now, and it's time to get it serviced, filters cleaned, things replaced, et cetera. So talk about thriving, right? An industry gets to thrive as a result of this being connected and the digital replica being available to everybody else. So that's a little bit of what we are trying to do with the home solutions, and taking advantage of smartphone, 5G connectivity, Wi-Fi, all of those things kind of coming together as a solution with the aid of a digital twin.
That's very interesting indeed. And I believe we discussed opportunities in the UX side in cities, factories, and our homes. What other unusual digital twin use cases you might foresee?
Hey, Ari, thanks very much. We talked a lot about all of the enabling factors, whether it's the user experience, whether we talk about the digitization, 5G, IoT. I mean, you kind of look at this as what is the art of the possible, right? And we've now set up with all of the emerging technologies and the enablers being in place to really drive the next generation of innovation. So, the way we kind of think about it, and the reason we formed our Cloud First Networks group is because we kind of see with 5G, it's a network of networks. It's a platform-driven capability. So moving network to cloud, enabling mobile edge computing, and then ultimately moving cloud to edge, this is what unlocks the innovation capability and driving new use cases, right? The foundational elements are all there, right? We've been talking about AI, we've been talking about machine learning, we've been talking about 5G. We've now scaled and adopted a lot of these technologies in enterprises, right? So what we kind of see as critical decision points going forward is, for a lot of the enterprises, is there's still only 65% of enterprises still underutilizing a digital twin, right? We're still thinking about it as a visualization tool, or we're still thinking about it as a way to kind of do some analytics capability. But we've talked a little bit about driving the next level of modeling around digital twins. I think we kind of think about it in three phases, right? One is to fortify, and we talked a lot about data being foundational. So my concept here is the foundational element of a data platform starts with auditing your data practices, looking at your data sources, looking at your technology uses, what tools are you using, And then really part of it is historical data, but also implementing real-time streaming to get to real-time data, right? And that's what 5G would unlock, is accelerating the collection of data from IoT. Today, enterprises, I would say about 12% of the executives are saying they only use 80% of the IoT data, right? So getting that foundational element of a platform is critical. And then I would think that as we kind of come out of COVID, during COVID, we all recognized that we were depending on historical data. So not having and making sure that you rely on historical data has changed really fast, right? Through COVID, what we found was within a week, the top 10 products being searched were all COVID related. And if you had these machine learning algorithms that were sitting there looking at historical data and not having real-time data integrated, it's going to be critical to kind of make sure you make the right decisions, as well as you make the right kind of foundational elements in terms. The second, I would say, is on top of fortifying, we kind of think about it as extending. And that extension is really accelerating the agility of driving the innovation cycle, right? So how do you innovate with these new, we talked a lot about the use cases. Here's the concept of accelerating that innovation and looking at your R&D cycle in a new way to accelerate new products and services. Second, I think the businesses themselves leveraging digital twins could think about the what-if scenarios in a more dynamic and rapid fashion. So evaluating business risk is kind of another way of extending the digital twin capability. The last, I would say, as we think about fortifying and extending, is really talking about a third element of this, right? How do you reinvent? And the concept is, as we see the adoption, about 65% of the executives said over the next 3 years, they're going to increase their investments in digital twins. But the concept of a digital twin integrated into a larger ecosystem of digital twins is really critical, right? So extending it outside of your enterprise and bringing your ecosystem partners into that is going to be critical, right? And so think about your API microservices strategy to make sure your digital twins can extend beyond the foundational elements of your own enterprise. So that way you can get integrated into the supply chain, into your manufacturing processes, and really get a good end-to-end view of how you drive the next level of innovation.
Thank you so much. It's great that you mentioned accelerating innovation, and with innovation means change, and change is sometimes scary and not appreciated. So with that, Timony, the adoption of new technologies can profoundly affect the way a society is constructed or behaves. So by twinning industrial machines, what cognitive, behavioral, technological, and conceptual changes we might face in the future?
One of the more interesting things about any kind of change doesn't have to be technological, but in this case, let's focus on technological because we're here today to talk about that, is how humans feel like we have to add a metaphor to something in order to define it or to make sense of it. I was just thinking as we were talking about the 90s when we all talked about the information superhighway, like when's the last time you used that term, right? And I wonder if digital twins is going to be one of those terms that makes sense to us now as we're trying to reason through what this new wave of computing looks like, but in 20 years, people might not be using this term at all because it just becomes the norm, right? It just becomes the way that we're used to interacting with all of our devices. I think for casual consumers, IoT is certainly the closest thing that we have. I think you were talking earlier about how our phones are sort of the heartbeat. I was thinking they're kind of the remote for everything and we interact with at this point. So when it comes to human behavior, there's a lot of kind of interesting, nascent, emerging behaviors that we hadn't expected or predicted. So, for example, on the internet, when you had a handle, do you remember having an internet handle back in the day? Now no one calls it that. There are people I've worked with that I hold in high esteem as colleagues, and I don't remember their real name. I only remember that their handle is like Steampunk29 or something like that. You know, like that's an emergent behavior that we really hadn't expected, which was sort of this casual embrace of a digital identity, knowing that there's a human behind it, but it doesn't really matter. We're just going to interact with them digitally. Extrapolating this out towards what we now know about how the next 10 years of computing will be, the rise of sensor information, the rise of real-time information, the rise of machine learning that has to deeply integrate real-time information quickly. I would think what we're going to see is a casualness, that casualness extended to how we interact with computers themselves. And I guess this is really just a layer on top of what I talked about earlier, which is that we can expect computers to have contextual awareness. And if they don't, and I think this is crucial if you work in computing, if they don't, people will be incredibly frustrated with them to the point that that could be a huge issue for your company, really. Like, if you've ever seen a small child walk up to a television screen and try to swipe, you know that we have these behaviors that are emergent today that will become de facto in the future. So if you don't have contextual awareness in your computing devices today, I think people will get so frustrated with that, and that will be table stakes in the future, that it would honestly be the death knell of some companies. In the same way, companies that didn't embrace networking early on or didn't embrace, really high quality computer graphics. I'm thinking about, BlackBerry versus iPhone. People just start to assume that the computers will behave in this way, and then, ignore the ones that don't.
Indeed, and with cultural evolution, we need social learning in our organizations.
We think about that a lot too. Like, the internet has become sort of the lingua franca of certain types of behavior. Like, regardless of what country you're from, for example, I'm on Reddit a lot, and there are specific behaviors that people have on Reddit regardless of country. And I'm curious to see if we start to see like emergent new behaviors, even more so, regardless of your cultural identity, that just have to do with your digital. Yeah.
Right. So there's another important theme that I'd like to discuss with our panelists, which is sustainability and circular economy. Claudia, what's your current work towards streamlining sustainable and resilient network sites?
Yeah, so basically, we are all discussing about the power of 5G, enabling consumer and enterprise use cases, and then the backbone of that is the mobile network. So what we observe is that as the 5G technology is accelerating, we need to make sure that we can expand the 5G network very fast and be very, very agile with it, right? But the reality of it is that today there are up to 20 documents in some cases to describe what's installed in a physical site. So think of CAD documents, Excel sheets, data sheets. So all this together, it's very slow and it's very prone to errors. So that's why we developed our site digital twin, where we are moving from all these data, papers, pictures, and things like that into one single 3D version of it that we capture using drones for the towers and then LiDAR and 360 cameras. So we have an exact replica of how the site looks like, but also together with all the metadata that is required to do a very fast and predictable lifecycle management. Things like how much weight can the tower handle, the power that is available there, the compatibility between different components. So in Ericsson, we have developed, I would say, the IKEA kitchen planner, but for telecom networks. So we have a library of 40,000 components, and then it's very easy to drag and drop, and then you can have this very quick maintenance. So in doing so, we have been able to reduce the design time by 50%, and then more importantly, and this is where the sustainability aspect comes in, we have reduced the percentage of site revisit. So that is, you go to the site, and then you realize something was wrong and you need to come back, from 1 in 10 to 1 in 1,000. So that is less travel to the site, less people having to climb. It's much safer and it's much more sustainable. So today I cover our network digital twin, our site digital twin, and then on the research side of the house, we are actually cross-pollinating between the gaming industry and telco. So we have a collaboration with NVIDIA, where we are using the Omniverse platform and all the capabilities that are available from the movie CGI industry. So we have very accurate representations of the city environment with all the materials covered to a very high level of detail. And this we use to cross these two things. So the very accurate 3D modeling, the network propagation, and then we are a third dimension, which is real time. So with the compute that is available from the gaming industry, we are able to model the subscribers and how they navigate this omniverse, and in doing so, we can evaluate, okay, how does the network behave, and then develop the products of the future.
That's very exciting, and even in our homes, Viju, if we have more control over the physical tools, and then we are tagging them in digital twins through sensors that are, can we predefine alerts or rules that promote sustainability and circular economy?
Definitely, yes. But let me set some context around, how we think about sustainability. Let me just do a field poll here. How many people have upgraded their smartphones in the last 2 years or 3 years or so? Show of hands. Oh, lower than I expected, about 70%. How many people actually traded in their old phone when you upgraded to a new 5G phone? Wow. So not very sustainable, right? I mean, think about this. I mean, people are throwing these phones back in their drawers because someday I may use them. Trust me, you don't. So, and by the way, you're leaving money in your drawers, which is it's a depreciating asset that continues to lose value. So, in the device lifecycle program that I talked about earlier, we do enable when consumers are coming to upgrade their phone. We work with, Deutsche Telekom, Telefonica, Vodafone here, AT&T, Verizon, KDDI, globally, almost all the carriers and retailers in trade-in programs so that we can promote sustainability. So to answer Ali's question about how does that translate to what's happening at home. So when you think about sensors that are transmitting data from these digital twins, you know how long these devices have been functioning. Manufacturers definitely know the lifetime of certain devices. So next time, it's not only an enablement for sustainability so that you can actually trade in components or upgrade components, et cetera, but it's also an incentive, just like how the mobile industry is doing, paying people in order to incentivize them to buy the next one. If you say you'll get a 10% discount on your next update of your smart speaker or something like that, people are a little bit more incentivized to go do that. So it benefits the consumer. It definitely benefits the manufacturer because they're able to make a sale, the retailer or the manufacturer. And most importantly, it helps the environment as a result of that. Less e-waste going down into the earth. And the thing about sustainability, though, what we have discovered is if you talk about it without an economic model, it becomes a very boring story very quickly, all intents notwithstanding. If you attach an economic model to it where everybody wins, sustainability becomes a natural part of what we do.
I believe we quite need these type of initiatives nowadays. Tommy, moving to a more technology perspective, in what ways is the digital twin technology an enabling technology for AI and big data?
Actually, it's a great question. I mean, AI has been in a buzzword and something we talked about for a number of years. And sometimes it's a bit misused. Sometimes automation is called AI. Sometimes its rule set is called AI, etc. But there is, true AI is emerging, right? But AI is essentially is programming code that is taught to do something. And like with any code, there can be good code and there can be bad code. And as such, there can be good AI. And I think we start seeing the emergence of maybe bad AI coding that, it's not developed as good as it could be. And as the AI learns more and more, it becomes, that deviation becomes bigger and bigger and bigger, and it does worse things. So I think digital twin is a perfect proving ground for test driving in AI. If you take the physical world around us with all the sensor data and you build a replica of you want your AI to do or take decisions about, and you can test it. And because we can feed massive amount of data, we can do a lot of testing and verification and retuning the AI. So I think digital twin is a perfect enabler for helping to advance the accuracy of AI, which I think is going to be really important. Because imagine a world going forward. We're sitting here in 5-10 years time, and we have a lot of AI out there that is, not performing as well as it should be. Then instead of decarbonizing industries, you might actually adding more carbon back into it. So it's very, very important that we test that. And also, a lot of people you talk to that doesn't really understand AI think, well, AI is just like one big thing. It can do everything. Well, it's not. You create an AI for the home. You create an AI to do process improvements. You create an AI for self-driving. I mean, self-driving is a big topic, right? And you have a car. You have a lot of sensors. You take a lot of information. But how do you improve the accuracy of self-driving. Well, if I create a digital world with all the data I have from a city with the traffic flow and road works, and you build all these things into it, and then you can teach that AI who will drive the car, who to react in all situations. And you know, one thing that we use a lot when we talk about digital twin is these famous words, Houston, we have a problem. You know, you go back to Apollo 13, where they built this fantastic machine to go to the moon, and then something unexpected happened, which was never even conceived or thought about. And all of a sudden, you have, you know, thousands of scientists at NASA trying to solve a problem which they never even thought could happen. You know, with digital twin, we can actually do that, but in a virtual environment. So very excited. There's a lot of potential. But I would leave you with the word of warning as well, because as we build these digital twin models, we feed vast amount of data into them. You know, they are prime targets for attacks, for cyber attacks. You're putting that much data, and especially these days when we can feed near real-time data into it. We also need to make sure that we build them in a secure way. We talk a lot about just putting data into the cloud. Well, you know, in many cases, we need to use edge compute. We need to put data closer to where it's actually used to make sure that we handle that data in a secure and responsible way. And I think that's also very important.
Thank you so much for bringing the importance of security, and also another thing, which is biases. Are we bringing our real-world biases to these digital twins?
Absolutely.
That's something to discuss and to study as well. Also, there's a lot of hype around the metaverse, Tejas. So what role other technology trends like 5G, metaverse will play in the maturity of digital twin technology?
I mean, yeah, we talked a lot about it in all of these different use cases, right? I mean, I just think the explosion in the adoption of technology over the last 15 to 20 years, I mean, the iPhone was launched, in 2008? It's been 14 years, right? I mean, the cycle of innovation, as we talk through all the stages of how we've seen computers going from mainframes to client server to devices, I just think we have now all the ingredients to really accelerate, right, what this thing could look like. I mean, I know these concepts are starting to accelerate in terms of understanding, but part of it's an educational piece of getting everybody to understand exactly what that all means. But, you know, I see the proliferation of 5G, proliferation of cloud and edge, as we talked about it, are all kind of key technology capabilities that you need to really accelerate the adoption of it. And I think metaverse is just another version of getting to a platform capability with real-time data, with the visualization capabilities to really unlock, as I talked about it, right, the innovation cycle, right? Getting new products, new services in every single industry. The acceleration, the agility that they need is really key. And I look at kind of 5G as being a foundational capability, right? It gets to cloud, it gets to edge, it gets you to massive IoT, so all of the sensor data that you need to get to. It gets you to low latency, it gets you to kind of broadband capabilities, right? So you combine all of those things together, you've untethered all these devices, they are finally connected, and that data is going to be foundational, right? So I kind of think about foundational intelligence, even in the digital twin, is built off of a data platform, right? And so getting those control points, using those control points to create kind of data products and models, using those data products to fabricate in real time new products and services.
Thank you so much. I think we still have 2 minutes left, and this is an open question for you all. If digital twins can bring a bit of certainty or transparency to, let's say, supply chain networks, how can organizations create a business strategy based on a digital twin of a real-world system? Or how can they start?
I mean, look, I'll take the first shot of, you know, I think as you think about the digital twin and you think about your strategy, I kind of go back to those 3 points again, just make sure that you've fortified your data, reimagine and reinvent. And that invention, in my mind, I mean, the biggest thing for enterprises to think through is not only creating the foundational elements of what it is that you want to collect data on and try to automate, but look outside of that enterprise into your ecosystem, because fundamentally the way to get to that next level agility is really connecting these digital twins. And so I think from an enterprise perspective, I think key to your digital twin strategy is also going to be making sure you build it in a way that it connects to other digital twins, right?
I think, digital twins are great. All of these connected technologies are great, but consumers are and should be willing to give up a little bit of information. So privacy is always a concern. So how do you putting in the tools to ensure that there is appropriate consumer privacy and there's protection around their data? That's going to be critical for letting people do that. I mean, cookies, now we don't even think about it, right? We just say, yeah, accept. I mean, otherwise you can't even get onto the website. So I don't even know what's going on with it anymore, but I have no expectation of privacy anymore. But but it's a critical element, even though I'm joking about it. It's a pretty critical component of it.
Totally agree.
Yeah, we think it's very important to build the digital twins, like he was pointing out, in a very modular way so that we can connect them and create, as I was saying, connect one with the other and then do something new. And then also manage the complexity of the system so that you can apply the digital twin into a commercial application so that you can solve a problem in a radically different way. So you have very tangible applications of the digital twin specified for certain problems and bring them to the next level.
True.
Strategically, just thinking about, particularly when it comes to digital twins, people often want like a real-time 3D interactive visualization of whatever system it is they're trying to either simulate or actually just sort of moderate. That 3D is really hard. Like I've worked for a 3D company for the last 7 years, and it has not gotten any easier in that time. So I think in the same way that companies learned they had to have an app, which means you have to have an app development team. Like this is just de rigueur now for most industries. We're going to see that same new type of team emerge as you have 3D visualizations. And this requires disciplines that are pretty common in the gaming industry and film, but really unknown to most other types of either technology or industry. So you're going to need 3D artists, you need animators and riggers. So strategically, if you're seriously considering moving towards real-time 3D visualizations, just be aware that those are going to be the hot new disciplines that people will be hiring for over the next decade.
Few seconds for final word. Okay.
Yeah, I mean, you say, how do you get started? I think what you will see is the digital twin industry is growing rapidly. It's always hard to say, how big is the industry? It's kind of like $3 to $5 billion, but we're expecting that to go up about 10 times in the next 5 years. I think you will see companies like SETI, other tech companies focusing and building platforms for various parts. Some might build platforms for logistics, and they build very specialized digital twin platforms that you as a logistics company can buy that service, feed in your data. Some big companies might build their own digital twin platform. So I think it will be a mix, but you will have companies building digital twin platforms for specific use cases, industries, and verticals like we are doing today.
Thank you so much to our panelists today for all the interesting insights, and thank you so much for attending today's session, and see you hopefully next year.
Thank you very much.